In this video, we continue with basic operations in GRASS GIS. So let's now query data. To query data, that means to find the values or attributes at certain location, we select the layer that we want to query. So let's select elevation and then click on the query icon and then click on the point which we want to query. So let's see this one. So then we will get the value at that location, and that's like 104 meters. We can also query vector data. So let's just display some vector data, such as the schools and streets. And let's select the schools layer and query one of the schools. So now we get some of the basic information about this layer, but also the list of these attributes. So for example, capacity of the school, grade, school's level, and so on. And we will talk and look at the vector data attributes later on. So then another basic operation is zooming in and zooming out. So let's just keep the streets wake. So we can zoom in like we would do in another software, or we can zoom out using this by clicking on this icon. And then we can also zoom to layer. So for example, we can select a layer such as streets wake, and we can zoom to this layer. And you can see this orange rectangle shows the computational region, but the display now is set to the extent of the streets wake map. So we have zoomed into that streets layer. And we can get back to the computational region by clicking on this icon. Okay, and then also let's switch here to the pointer. Now let's display this or go back to the statewide DM that we had displayed at the very beginning of our previous video. And we will display the statewide digital elevation model and some additional vector data. So how do we get to that? Let's do it through the command line. So let's copy this set of commands and we can paste it into our console. So we can start with setting the region to the entire North Carolina. And instead of using the raster, setting region to a given raster, here we will be setting region to a predefined region, which we have in our database. Then we won't really focus, so we can now zoom to that region. And as you can see, these are our layers that we have displayed. So we can remove them from the layer manager because we want to look at the entire North Carolina. So you can either do it like this and remove them, or we can just run the erase command. And this will remove all those layers. And now we can display the statewide digital elevation model. We can display the meteorological stations for which we have the precipitation data. And we can add the county boundaries for orientation. And we can then save this file save this image into our folder that we have set up into our working directory. And we can then look at that working directory to make sure that we have everything there. So here are the maps that we have generated so far. So now let's look at some tools for managing the data. So if we want to list the existing data, we can either look into the data catalog, and as you can see, the permanent map set has quite large number of map layers that we have prepared for this course for you to work with. We can also list these map layers using the command g.list. And now they will be displayed in this panel. So there is quite a few of them. And with -f flag, we also get a description. So this is the title of the map. So a little bit more information than what we have here. Now, if we need, for example, if we are working on a script and we just need to select certain subset of these data layers, we can search or list the map layers based on a pattern in their name. So, for example, let's just list all the layers that start with S. So here they are. And then we can also look at what kind of regions do we have defined. So you may remember that we have set the region to a predefined region. So what are the other ones that we have there? So here is our NC 500 meters, but there are some other ones that we will use later on. Now, another very common operation is copying and removing the data. It is important to keep in mind that copying and removing the data always should be done using the GRASS tools. Never use your computer file manager to move around the data, because that breaks the data structure and you may lose an important information. So for example, let's now copy a geology map layer and the raster geology from permanent map set to our map set, to the one that we have set up for the assignment. So we can check whether it's there. So now we have that raster layer in our map set. So let's display it. And we can zoom to that layer. And let's say once we have it copied, we can alter it because the map layers that are in permanent, we cannot change them. So we can, for example, change the name of that file or that data layer. And then we can do things like we can reclassify these layers to something different. So if we query this layer, we have the label of that geology type. And if we want, we can, for example, based on these types, we can reclassify it to something else, or we can change the color table and things like that. To remove this raster layer, then let's say we have really broken it and we don't really like to keep it, so we can just remove it or delete it here, or we can use the command line. So let's now use the command line for that. But you have seen that I can do it very easily in the data catalog. Mhm. So we can just list all the raster data layers. So here is the, and then we can remove the one. So here is that my geology, and we will just remove it. So these are again like basic management of data, and I just wanted to highlight again, just don't do it outside GRASS, don't move these layers, just do it using the GRASS tools. Now we have already used the command r.info that gives us the information about the raster layer. So let's just do it again. So here I always highlight, look at the rows and columns, make sure that you don't have some massive raster layer when you are working with in your project, so that you have the data that you can actually work with. You also want to be aware of the resolution, so you need to connect to the 10-meter resolution with the features that can be actually represented at that resolution. And you also get here an information how this data layer was generated. And you can see that it was reprojected from some latitude longitude data using cubic reinterpolation. And we will talk about how to do this and what are the properties of these different methods next week. So we can find information about the vector data. So it tells you how many lines there are, and if it was areas, so it will tell you some statistics about the areas, and of course it will give you the spatial extent, the coordinates. If we want to know also the attributes, so we can list these attributes using the -c flag. So again, you can see a large number of attributes for each road. A lot of them are really related to being able to use this layer to do network analysis. So now let's look at another important and very common task that we often do when working with geospatial data, and that's import and export of raster and vector data. So let's now import a shape file. So here we have a shape file, which in this zipped file. So let's download that file. And we do it again into that current directory so that we don't have to define the path to it. And I have it already there. I will download it again. Now let's unzip it. And you can see that in this folder we have actual shapefile with the projection information and with the attributes. So now we can import that file, and you can see, let's now use tools tab. So in the tools tab, you have access to to all of the tools that are available in GRASS. So for example, all the import export tools in raster. You have again all the tools for performing various analysis, let's say solar radiation, terrain analysis, lots of tools. And so let's look at the import vector data. And uh, we can use viimport or vinogr. So let's just follow the instructions here. So let's do the viimport. This will open the graphical user interface. We will find the file. Okay. And I need to go to the to the directory where I have the shape file. So let's just look at what it is. Mhm. Hmm. Oh, I downloaded to test. Oh, no. So I downloaded it to the wrong directory. So now I have to deal with it. Okay, so it's here. So we can, if you download it to the wrong directory, not the current directory, then you can just go to that directory and find it, browse to it. Okay, so I have here the shape file, and let's import it. And it automatically displays in the uh, it is added to the data layer, and it automatically displays in the map display. Now, in the assignment, you have a question on how are the imported geodetic data points spatially related to the street's wake. So, so now you have to think about it. How can you compare it with the street's wake? So we have, for example, you can zoom in, and you really want to add the street's wake uh, to the to the map, to the display. So we can zoom it zoom in even more so that we can see a little bit more detail. And let's see, let's change the color of the imported file to red so that we can see them better. So now you can better see the association of these red points with certain features in the in this area that are displayed. So now you have to answer that question. Now, how do we export a file? So let's look at the tools. So here we have import vector data. So let's export vector data. Common export format. So we want to export the roads major. And we will write a shape file, and now it will export it to our working directory. So let's check it. So here is that shape file that we have now exported. So for example, if in your project you want to generate some vector data and you want to bring them into some other software, you can export them from GRASS. Then you can do a similar operation with raster format, import the raster data layer and export the raster data layer. So again, we will download the data set, and let's make sure that I download it to the current directory. That's the report. Okay. And let's try to import it using the command line. So we can do it with the interface. There it is. See. And now we have lots and lots of layers here. Okay, this is the error that we are getting. So I left the geology map, my geology map uh, that we have removed in the map layer, and I need to remove it to get rid of that error. So this is the land use data layer that we just imported. And let's zoom to that layer. to see how big it is. It just fits to this to our computational region. And now let's export some data. So let's say we have generated basins for our area, and we want to export it. But let's first look at that data layer so that we know what we are exporting. And that's the basin. Okay, so here are the basins in our study area. And we will export them as GeoTIFF file. And then we can also, as an example, we can also export the digital elevation, 30-meter digital elevation model in a different format. So let's now look at our current directory. So here we have this exported data that we can then import into some other software. Now let's see, in this project we are using meters, and we are focusing on Southwest Wake County, and we have also some data for the entire North Carolina. Uh, and we have some new data and a new project where we are working with the local government, and the local government asks us to work in the coordinate system, which has EPSG code 3404. So let's now create a new project by clicking on this icon, which says create new location, but that's essentially the same as a new project. And we will call it local government data. We don't need any description. And then we were given the EPSG code, so we will create this new project based on the EPSG code. But you can also, if you were given, for example, instead of EPSG code, some shapefile or some other georeference data file as a starting point, you can create this project using the coordinate information from this data layer, from this data set. So let's just do it this way. Now we will just type that number here. So here is the description of that coordinate system, and you can also read its parameters. We don't need to apply any transformation. And here you have the list of the parameters for that coordinate system. And what you may notice is that this coordinate system uses feet as units, and this is very common for local governments here in North Carolina. So we are using North Carolina state plane coordinate system, but now with units feet. So what you will see that we will switch to this new project, and it's referred as a location with local government data. Okay. And now what we can do, we can, for example, copy some data from our project in meters to our project in feet. So, for example, let's do those basins. Copy. And then we will paste it here. And we will get an estimation of the resolution in feet and the method, how it is resampled, and a notification that the data will be reprojected. And we can display them here, but now we are working in feet. Mhm. So, and the last task that we will do, we will add WMS layer. So now let's switch back to our previous project and our previous map set assignment 1, and we will just switch map set. So now we are back. And what we will do, we will now zoom into another predefined region, and it's rural region at 1 meter resolution. As you can see here, here is the resolution, here is number of rows and columns. And let's just display the orthophoto. And now we want to zoom to that computational region because we were looking at the entire North Carolina before. So once you zoom into that computational region, we now see where we are with the where this location actually is. And we can add from permanent streets wake, just for orientation, let's just zoom out, or let's just, yeah, so that we can see where it actually is. So here is one of the highways. So it is south of that highway, and this is the entire orthophoto. And within that orthophoto, we have identified this region that will be used later on in class for some of the modeling tasks. So let's zoom back to computational region. And let's now try to get more up-to-date imagery, because this one is from 2001. So in Layer Manager toolbar, let's just look at and click on the icon, add the WMS service. Here we can copy the server. So now we are connected to this server. We need to switch to WMS 1.3. And then let's open this data set. And we can see that in this data set, we have several products. So what we can do, we can select, let's say, natural color orthophoto. And add it as a layer. So you can see this is higher resolution, more detail, and the landscape has changed significantly. And just for comparison, we can also select and import NDVI color. Okay, so we are now getting information about the greenness. So you can see like low greenness where we have water and roads, and some of the fields have variable greenness based on the vegetation. Now to save the layer, save web service layer. Mhm. Now it is still importing it. Mhm. And eventually it will show up in your assignment directory. And now let's also save the NDVI. We could have um, clipped it to computational region. Here it is downloading everything that is in the display, so we are getting a little bit wider region, and the saved maps are added to the map layer. Okay, so now we have done all the tasks for this first assignment, and we can save if we want to save the maps that we have in the map layers, we can do it, and we can save it as a workspace. And again, it will go into our directory, into our current working directory. So if we want it to work again with these orthos, we will just open this file and it will automatically load all the layers that we have there. So now we can quit grass. Now, here, if you forgot to save the workspace, you can do it now. It reminds you, but we have already saved it. Okay, so that's all for this first assignment.